Okay, good afternoon. Today's topic will be your subject ECE 6201 Electromagnetics 1. Okay, I'm your OLC from Engineering Department. Today's topic will cover optics and geometric optics. Okay, let's start. Okay, let's start by the definition of an optics. As you can see in this lecture, an optical phenomena involves the interaction between the electromagnetic waves and matter. We will focus in visible, infrared, and ultraviolet light. Yan yung mga example ng mga electromagnetic waves. For example, katulad nga ng visible light, tsaka mga infrared, tsaka ultraviolet light. But much of the study of optics will apply to some extent to radio waves and X-ray. Okay, usually yung optics na definition natin, isang application nito usually, isang mga radio waves, yung nagtatransfer tayo ng electromagnetic waves from transmitter, then marireceive naman yun through the receiver. Then dun sa transmitter, it will be modulate para ma-transfer or ma-transmit siya papunta dun sa receiver in a long distance. Then meron din siyang medium na ginagamit. Katulad dito, in the form of optics or in some extent of radio waves and X-ray. The complete study of optics involves enormously complex mathematics and true understanding of both classical and quantum optical effects and a great deal in equity for success. Okay, yan yung definition ng optics. Usually, study of optics applies to some extent of radio waves and X-ray. Okay, continuation. For the purpose of this course or subject, the optics will be limited to classical description of electromagnetism provided by Maxwell equation. Okay? Yung didiscuss natin ngayon is paano nakaka-affect yung optics or yung magiging relationship ng electromagnetism na dun sa equation ng Maxwell equation at saka yung optics. Then at full wave optics, for example, in this level of description is quite complicated for most optical phenomena, so we will apply simplified models to develop a basic understanding of how optics works. In geometric optics, we assume that all light travels in straight lines, and in paraxial optics, we assume that all optical systems handle light rays near a symmetry axis of the optical system, then which allow us to largely ignore a variation and a vast array of terribly complex optical effects. Okay, that is the optics. Okay, today ito nga yung pag-discuss natin ngayon. How is the size and the location, nature of images by using the mirror and lens equation. Then we also discuss the law of refraction in the optics or in geometric optics. Then the effect or the type of law like refraction and reflection. Ano ba yung nagiging effect nito dung ng optics through refraction and reflection kapag nangyari ito. Okay? Okay, the introduction, as I said before, optics deals with the propagation of light through transparent media and its interaction with mirrors, lenses, slits, and other. Then optical effects can be divided into two broad classes. Firstly, those which can be explained without reference to the fact that light is fundamentally a wave phenomena. And secondly, those which can only be explained on the basis that light is a wave phenomena. Okay, since ni-discuss natin yung optics is may kinalaman to sa pagpapropagate ng light through transparent media. Okay, then the interaction also with mirrors, mga sample na lenses, yung mga ganun. Then, optical effects can also be divided into broad classes. Una nga is yung which can be explained without reference to the fact that light is fundamentally a wave phenomena. Then yung second naman na broad classes is which can only be explained on the basis that light is a wave phenomena. Okay? Okay, next. The moment consider the former class of effects it may seem somewhat surprising that any optical effects at all can be counted for without reference to waves. After all, light is a wave phenomena. It turns out, however, that the wave effects are only crucially important when the wavelength of the wave is either comparable to or much larger than. Okay, alam naman natin yung wavelength is the formula is lambda equivalent to C over F, where C is yung speed of light since optic ang ginagamit natin, or light yung type ng electromagnetic wave, that is ang value niya is 3 times 10 raised to 8 meter per second. Sobrang bilis ng transmission ng data or ng signal. That is C over F. That is 3 times 10 raised to 8 meter per second. Divide natin sa operating ng frequency. Kaya ang effect ng wave is only crucially important with the wavelength of the wave is either comparable to or much larger than. Then the size ng object naman, for example, which is interact, is when the wavelength of the wave becomes much smaller dun sa size ng object na mag-interact ito, then the interaction can be accounted for a very simple geometric manner. Okay? Okay, now we will discuss the wavelength of a visible light. The wavelength of a visible light is only of order a micron. Okay, usually ang unit ng wavelength is naka-micron siya or sobrang liit kasi nga ang formula ng wavelength is lambda over C over F, where C is yung speed of light, divide mo dun sa frequency. Kaya nangyayari kung inversely proportional yung frequency at wavelength, since matataas na frequency ang ginagamit natin pagta-transmit ng data or information through a communication, kaya ang nangyayari sa wavelength is nasa micron siya or sobrang liit ng value. It is very easy to find situation in which a wavelength is very much smaller than the size of the object with which it interact. Thus, waveless optic, which is usually called the geometric optics, has a very wide range of application. Maraming application ng geometric optics. Okay, meron tayong 3 laws na ginagamit sa geometric optics. In geometric optics, light is treated as a set of rays, okay, emanating from a source which propagate through transparent media according to a set of 3 simple law. Okay, meron tayong tatlong law na ginagamit sa geometric optics, wherein it depends on the light. It is treated as a set of rays, then emanating from the source, then which propagate through transparent media. Okay, transparent media yung doon nagpo-propagate yung light or in geometric optics. Okay, the first law is the law of rectilinear propagation. Pag sinabi natin rectilinear propagation, which state that light rays propagating through a homogeneous transparent medium do so in a straight line. So kaya nangyayari sa first law kapag law of rectilinear propagation is yung light rays natin na ginagamit is nagpo-propagate siya through a homogeneous transparent media in a straight lines. Okay? Okay, the second law naman, the second law is the law of reflection, okay, which govern the interaction of light rays with the conducting surface, katulad ng mga metallic mirror. Okay, that's the second law. That is law of reflection. Nagre-reflect yung light rays dun sa transparent medium, or in this one is conducting surface, which govern the interaction of light rays with conducting surface, katulad ng mga metallic mirror. Then dun sa third law naman, the third law is the law of refraction, which govern the behavior of light rays as they traverse as a sharp boundary between two different transparent media. Okay, yung sa third law naman is law of refraction, nag-refract itong light rays na ginamit. That is govern the behavior of light rays as they traverse a sharp boundary between, katulad ng mga different transparent media, ito yung air at glass. Okay, yan yung nagiging medium. Okay, now we will discuss the law of geometric propagation. Okay, ano ba yung law of geometric propagation? According to geometric optics, an opaque object illuminated by a point source of light casts a sharp shadow whose dimension can be calculated using a geometry. Then the method of calculation is very straightforward. Then the source emit light rays is uniformly in all directions. Then these rays can be represented as a straight line radiating from the source. Then the light rays propagate away from the source until they encounter an opaque object and which point they stop. Okay, ganyan yung nangyayari sa geometric propagation. Is, for example, is meron kang light cast in a sharp shadow, yung nagkakameron ng shadow, kumbaga naharangan niya or nagkakameron ng object, katulad dito is may opaque object na nakaharang dun sa light cast, then magkakameron ng shadow. Then the method of calculation is very straightforward. Then the source of emits light ray uniformly in all directions. Okay, ganyan na nangyayari. Yung source ng emits light ray is uniformly in all directions. Then these rays can be represented as straight line radiating from the source. Then the light rays propagate away from the source until they encounter an opaque object. Okay, pag sinabi natin yung light rays nagpo-propagate away habang lumalayo siya dun sa source, is then nagkakameron na encounter dun sa opaque object. Then at which point they stop. Okay, ganyan ang itsura ng opaque object illuminated by extended light source. Okay, ito yung light source. Yung may circle, then this one is the obstacle, then we have called the umbra, then penumbra, then we have a critical light ray, then the obstacle. Okay, ganyan ang nangyayaring illustration. For example, for a discussion, continuation, for an extended light source, each element of the source emits light rays just like a point source. Then these rays emanating from different elements of the source are assumed not to interfere with one another. Then figures show how the shadow cast by an opaque sphere illuminated by a spherical light source calculated using a small number of critical light rays. Then the shadow consists of perfectly black disc called the umbra. Okay, ito yung sa umbra. Makikita natin since may obstacle siya, then meron pa ring light source, is yun yung umbra. Okay, that is umbra. The perfectly black dish surrounded by a ring of a gradually diminishing darkness called naman na penumbra. Yung sa penumbra naman is yung sa may taas dito, is ito yung surrounded by a ring of gradually diminishing darkness. That's called penumbra. Then next, in the umbra, all of the light rays emitted by the source are blocked by the opaque sphere. Okay? Dito kasi sa umbra is lahat ng mga makikita natin, since nasa likod lang siya na obstacle, is naharangan siya ng obstacle para dun sa light source. Kaya nangyayari, in the umbra, all of the light rays emitted by the source are blocked by the opaque sphere. Where areas sa penumbra naman, where areas in the penumbra, only some of the rays emitted by the source are blocked by the sphere. Okay, kaunti lang yung nabablock nung obstacle. Meron pa rin makikita na light dun sa penumbra, galing dun sa light source. Okay. Next, as well known to the ancient Greeks, if the light source represents the sun and the opaque sphere, then the moon, then a point of the Earth's surface which is situated inside the umbra, the sun is totally eclipsed. Okay, ganito rin yung representation. Kung ang light source is for example, ang light source natin is yung sun, okay, sobrang laki niya, then yung opaque sphere naman, yung nakaharang, is yung moon. Kaya nangyayari is nagkakameron ng total eclipse or naharangan yung light source. Then the opaque sphere naman yung moon nga, and the points of the Earth's surface, which is situated inside the umbra, and the sun is totally eclipsed. Okay? Where areas at the point of the Earth's surface, which is situated in the penumbra, then the sun is only partially eclipsed. Okay, since yung sa sun naman is yung sa penumbra, since yung sa Earth naman is yung sa penumbra, may mga part pa rin na makikita galing dun sa light source or dun sa sun, kahit naharangan siya ng obstacle or ng moon. Okay? Kaya ang nangyayari is it's only a partially eclipsed kapag penumbra. Kapag umbra, that is totally eclipsed naman. Okay, next. Okay, now we will discuss the relationship between the wave fronts and the light rays. Okay, makita natin sa light rays, that is continuation, nakakat yun yung pa-arrow na horizontal. Then the wave front, ito yung broken arrow or broken line. Makikita natin na nasa vertical. Okay, that is the illustration. Or the relationship between the wave fronts and the light rays. Okay, let's discuss. In the wave feature of light, a wave front is defined as the surface joining all adjacent points on a wave that have the same phase. Example is all maxima or minima of the electric field. Then a light ray is simply a line which runs perpendicular to the wave fronts at all points along the path of the wave. This is illustrated in this figure. Thus, the law of rectilinear propagation of light rays also specify how wave fronts propagate through homogeneous media. Okay, makikita natin dito yung law of rectilinear. Okay. Yung law of rectilinear propagation, ibig sabihin that is straight line yung kanyang pagpapropagate ng light rays. It's also specify how wave fronts propagate through homogeneous media. Okay, makikita natin yung wave fronts, yung broken line na nasa vertical. Ito yung nag-illustrate kung paano yung law ng rectilinear propagation sa light rays. Okay, makikita natin siya, broken arrow, yan yun. Then next, of course, this law is only valid in the limit where the wavelength of the wave is much smaller than the dimension of any obstacle which is encounters. Okay. Now we will discuss the law of reflection. Okay, as you can see, these are the law of reflection. The law of reflection governs the reflection of light rays of smooth conducting surfaces, such as polished metal or metal-coated glass mirror. Okay, pag sinabi natin reflection, nag-reflect siya yung light rays into of smooth conducting surfaces. It is the reflection of the light rays of smooth conducting surfaces, such as yung mga katulad ng polished metal or metal-coated glass mirror. Next, consider a light ray incident on a plane mirror as shown in the figure. The law of reflection states that the incident ray, then the reflected ray, and the normal to the surface of the mirror all lie in the same plane. Then furthermore, the angle of reflection is equal to the angle of incidence. Okay, and yung i-discuss natin, I will have a figure or example. Both angles are measured with respect to the normal to the mirror. Okay? Ito yung law of reflection. Ibig sabihin, meron tayong incident ray, then the reflected ray. Then it will be on the normal to the surface of the mirror, all lie in the same plane. Okay, ganyan na itsura. Meron tayong makikita na sa left side. That is the incident ray. Then makikita natin sa gitna, it will be bounce or mag-reflect. Then it will have the reflected ray. Then usually, kung hahatiin natin yung normal is na nasa 90, then it will be equal to angle of 45 degree. The angle of incident ray and the angle of reflected ray. Equal lang sila. Then yung nasa horizontal, that is the mirror. Okay, ganyan ng law of reflection ng light rays through the use of a mirror. Okay, now we'll discuss the law of reflection. The law of reflection also holds for non-plane mirrors, provided that the normal at any point on the mirror is understood to be the outward pointing normal to the local tangent plane of the mirror at that point. For example, for rug surfaces, the law of reflection remains valid. Then it also predicts that rays incident at slightly different points on the surface are reflected in completely different direction. Because the normal to a rug surface varies in a direction very strongly from point to point on the surface. Then this type of reflection is called the diffuse reflection. Okay, bakit nagkakameron ng diffuse reflection? Kasi nga ito yung mga gawa ng non-shiny object. Ibig sabihin, hindi perfect yung pagkaka-reflect ng light rays. Because it's also for the effect of the four rug surfaces, yun yung effect nun. Then the law of reflection remains valid also, but it can predict that rays incident and slightly different points on the surface are reflected in completely different direction. Okay, ganun yung effect. Kasi, or because the normal to a rug surface varies in direction very strongly from point to point on the surface. Okay, that's why it's called the reflection is diffuse reflection. Okay, now we'll discuss the total internal reflection. Okay, ano ba yung total internal reflection? An interesting effect known as a total internal reflection can occur when light attempts to move from a medium having a given refractive index to a medium having a lower refractive index. Suppose that light crosses an interface from medium 1 to medium 2 where N2, yung medium 2 natin is greater than the N1 na medium. Okay, according to Snell's law, ito yung formula niya, sin theta 2 is equals to N1 o yung medium 1, divide natin sa N2 or the medium 2, sin theta 1. Okay, that is the formula. Where since N1 over N2 is greater than 1 or greater than, it is follows that angle 2 is greater than theta 1. Okay. For relatively small angle of incident, part of the light is refracted into the less optically dense medium, and its part is reflected. Then the condition when the angle of incident is theta 1 is such that the angle of refraction theta 2 naman is equals to 90 degree. Then the refractive ray runs along the interface between the two media. This particularly angle of incident is called the critical angle. Okay, yung kanina, meron naman tayong tinatawag na critical angle. Kung kanina meron tayong angle of incidence tsaka reflected angle, ngayon is meron tayong tinatawag na critical angle. That is the refractive ray runs along the interface between the two media. Then these are particular angle of incidence called the critical angle. Okay, ano naman mangyayari kapag ang theta 1 is greater than critical angle? That will be no refracted ray. Okay, di magkakameron na refraction. Instead, all of the light incident on the interface is reflected. This effect is called the total internal reflection. And occurs whenever the angle of incidence exceeds the critical angle. Now, yung theta 1 natin will be equal to theta c or critical angle. It will have theta 2 equals also in 90 degree, and sin theta 2 will be equals to 1. Then the equation will be sin theta c or sin critical angle equals to N2 over N1. Okay, next. Okay, ganyan na itsura ng total internal reflection. Wherein, for example, meron tayong medium 1 sa baba, medium 2 yung sa taas. Then interface yung nasa gitna na. Then yung pinapakita dito sa left side, these are the reflected ray. Nag-reflect na siya from the interface. Then as you can see, doon sa pangatlong arrow na nasa baba, is dito yung critical angle. Okay? Then, dun sa pinakalas naman is yung total internal reflection na. Okay, next. Okay, for example, consider natin, consider a fish or a diver swimming in a clear pond. As figure makes clear, it's the fish look upward. It sees the sky, but it looks at the too large at angle. To the vertical, it sees that the bottom of the pond reflected on the surface of the water. Okay, then the critical angle to the vertical at which the fish first sees, then it is the reflection of the bottom of the pond, of course, equal to the critical angle for the internal reflection at air, water, and interface. Then, from this equation, the critical angle is, ito yung magiging formula natin. That will be this one, for example, the air, then these are the surface, then in left side, these are the critical angle, then the bottom, at saka yung water at yung fish. Okay? That is the fish eye view. Okay, next. Okay, when total internal reflection occurs at an interface, the interface in questions acts as a perfect reflector. This allows 45-degree crown glass prism to be used in place of mirror, then to reflect lights in a binocular. This is illustrated in the figure, then the angle of incidence on the side of the prism are all 45 degree, which is greater than the critical angle of 41 degree for a crown glass at an air glass interface. Okay? For example, sa material naman na diamond ang ginamit natin, for which ang material ng diamond are equal to N equals to 2.42, have a critical angle, theta C, which is only 24 degree, then the facet of a diamond are cut in such a manner that much of the incident light on the diamond is reflected many times by a successive total internal reflection before it escapes. These effects give rise to the characteristic sparkling of cut diamonds. Okay, next. Total internal reflection enables light to be transmitted inside thin glass fibers. Then the light is eternally reflected off the sides of the fiber, and therefore follows the path of the fiber. Then light can actually be transmitted around corner using a glass fiber, provided that the bends in the fiber are not too sharp, so that the light always strikes the sides of the fiber at angles greater than the critical angle. Then the whole field of fiber optics, which is many useful application, is based on this effect. Okay.